Hi guys, we're moving on to chapter 3 now. The first lesson is inequalities in their graphs. You're going to see this chapter is a lot like chapter 2, but everything's going to be inequalities now instead of equations. So our objectives here are to write, graph, and then identify solutions of inequalities. Okay, you definitely want to make sure you know these symbols. These ones right here. This is less than, greater than, less than or equal to, and greater than or equal to. The only difference between the first two and the last two is if you have that line under it, you have that or equal to part, and I'll show you what that looks like, why you need that when it comes for the graph. But if you have trouble deciding is this one less than or is this one less than, I try and think like this one right here, if you're going to write it like this, if you would just straighten it out a little bit, like this is kind of an exaggeration, but straighten it out like a lot, it kind of looks like an L. So that's the one that's always less than. Like, I know it's a pretty big exaggeration, but if it helps you, that the one that's going that way is always less than, and then the opposite way is always greater than, and then you have the or equal to part. So you definitely want to make sure you memorize all those symbols. If you have to make flashcards or whatever, definitely make sure you know all four of those. Okay, now problem 1, writing inequality. So the question is, what inequality represents the verbal expression? So part A is all real numbers x less than or equal to -7. So we definitely want to use the variable x. And then this part right here, less than or equal to, that's going to represent your symbol. So if it says all real numbers x that are less than or equal to -7. This right here represents all the numbers, and then we have our less than or equal to -7. Okay, now, I'm glad they have this on part B because you really have to be careful here. This says, part B says 6 less than a number k is greater than 13. So you have less than, and you have is greater than. Your key word here that you're really looking for is the is part. Like, that's going to clue the greater than, less than symbol. This part right here, 6 less than a number k, that's what we did in chapter 1. That's when you write k. That's when you write k minus 6. 6 less than a number k is greater than. So that's when we put in the greater than symbol, 13. And then in the next chapters, we're gonna learn to solve this. If it's k minus 6, you're just gonna add 6 to both sides. But be very careful when you have the less than, and then even if you had another less than in the problem, you're looking for that is part. That'll help you decide if you're using the inequality symbol or the subtraction for less than. Okay, the vocabulary here, the only real thing is a solution of an inequality is any number that any number that makes the inequality true. So when we had equations, if we had 2x equals 6 and we solved that for x would equal to 3. Because if I did 2 times 3, I got 6. Exactly 6. Now, inequality, the in part of it means not equal to. So we're not making equations. If we have this example here, the solutions of x less than 5. Any number that's less than 5 would be a solution. So numbers less than 5. You can check some. Is 4 less than 5? You would say yes. Is 0 less than 5? You would say yes. Is 6 less than 5? You would say no. So now, instead of having just one number, like in equations, we have one number, x equals 3. In inequalities, we're going to have a whole range of numbers, and we're going to have to shade on a number line to represent all the numbers that are solutions. Okay, so again, a solution of an inequality is any number that still makes the inequality true. So let's see, problem 2, identifying solutions by evaluating. So here's our inequality. We have 2x plus 1 is greater than -3. And the first number they want us to check is -3. So you still do the same thing. You substitute that in for x. So we have 2 times -3 plus 1. And we're checking to see if that's greater than negative 3. So 2 times negative 3 would be negative 6 plus 1. Negative 6 plus 1 would be negative 5 greater than negative 3. Now, is that true or not? Remember, when you have negative numbers, negative 3, even though it's a 3, is actually bigger. So, is the number a solution of the inequality? For part A, we would say no, because this is not true right here. Negative 5 is not greater than negative 3. Okay, and let's check part B. So we have 2x plus 1 greater than negative 3. That's kind of like the question we're asking ourselves. Then, if we plug in negative 1, is that still greater than negative 3? So 2 times negative 1 would be negative 2 plus 1. Negative 2 plus 1 is negative 1. Is that greater than negative 3? That's yes. So negative 1 is a solution. Negative 3 is not a solution. Now, this chart right here I took from page 165. I think it's really important that you copy this down to have this in your notes. I'll go through this and then we'll do a couple more practice problems so you can kind of see what's happening here. But with equations, when you solve it, you get one number. Like for instance, right here, instead of n less than 1, we would have n equal 1. But now if we have n less than 1 and we want to represent all our solutions, what you do is you put a circle on the 1. Okay, so you put a circle right here. Now, because it's just the numbers that are less than 1, you're definitely going to shade all the numbers that are less than 1. But you don't want to color in the circle at 1. You want to leave it as an open circle or an open dot, because this is just saying strictly less than 1. Technically, 1, if you plug in 1 for n, 1 is not less than 1. That's false. So you can't shade in 1. Now, if it was 1 less than or equal to 1, that would be true because of the or equal to part. So you look here on the second one, a greater than or equal to 0. You put your circle on 0, but you're actually going to color this one in because of the or equal to. And then you want to shade the numbers that would be greater than 0. For this one, f is greater than negative 3. You put your number right here on negative 3. Because it's just greater than negative 3 and it doesn't actually include negative 3, you don't color in your circle. Then you want to make sure you shade all the numbers that would be greater than negative 3. And then when I get ones like this, if I have negative 2 greater than or equal to x, I always like to rearrange it so that the variable comes first. So that's fine. Just make sure you keep the x and the negative 2. And then you have to keep the symbol pointing the same direction. So if right now I had it like this with the pointed end towards the x, I have to make sure when I flip it around that the pointed end is still facing the x. Like you can't switch the x and the negative 2 and then not flip around the equal sign. So this is definitely going to be on negative 2. It's going to be colored in circle because of this or equal to. And then if I read it this way, x is the number we're shading, so we're going to shade the numbers that are less than negative 2, which would be that way. Okay, you can copy that down. At the end, there's a key concept box that probably might be better for you to copy down, but either you have this or you have the thing at the end. I think it's really good to have in your notes. Okay, definitely copy this down. It's real short. If you have open circles, okay, open circles go with these two symbols, less than and greater than. Closed circles, and by that I mean a circle and you color it all the way in, go with greater than or equal to and less than or equal to. And it's because of that or equal to. If you have that line, you have to color in your circle. This part right here, the circle goes on the boundary number. That's the number the inequality is solved for, because eventually, and you don't have to write this down, but we're going to get things like x minus 5 is greater than 2. You don't want to put your circle on minus 5 and you don't want to put it on 2. You want to solve this first. So it's actually going to be on 7. So that the circle goes on the boundary number. That's just when the inequality is actually solved. And then you want to make sure that you shade all the numbers that make the inequality true. X represents the numbers that you're shading. So if x is greater than 7, you want to make sure you shade numbers that are greater than 7, like 8, 9, 10, 11, and out that way. Okay, so problem 3 is graphing inequalities. Now, when you have to make the graphs, so it says what's the graph of 2 greater than or equal to a. And again, I don't like to read them. I like to just flip them around, so I always flip them around and put the variable on the left side. It just, I don't know, that's the way I like to read them. But remember, if it was pointing towards the A, it still has to be pointing towards the A. So when you do these, you don't have to make a full number line. You need to put 0, and then you need to put 2, and then what I always do is I put -2 so that I have both halves of the number line. Okay, so if A is less than or equal to 2, we're going to put a circle on 2. We're going to color in the circle because the inequality symbol is less than or equal to. So 2 is a solution here. And then we're going to shade. A represents all the numbers that are less than 2. So you have to think, numbers that are less than 2, is that this way or is that this way? The numbers that are less than 2 go out this way. And you actually want to shade on the number line. Some people like to do this and just draw an arrow coming out that way. I mean, that shows that you're shading the right way, but all these numbers like 1, a half, -1, -1/2, every number on this number line is a solution to this inequality. So you definitely want to shade the actual number line. Okay, and then the next one is what's the graph of c is greater than 0? Well, if I told you have to put 0, you might as well pick any numbers you want, like 5 and -5. As long as you have 0 and then a positive and negative, I'll probably give you a number line on the test, but if you had to make one, you can just make it like that. Okay, so the circle goes on 0. I'm not going to color it in because it's just strictly greater than, not greater than or equal to. And then if c represents the numbers that I'm shading, I'm going to represent numbers that are greater than 0, and the numbers going out this way are greater than 0. And that's it. Okay, now writing an inequality from a graph. So first thing you have to decide, you can use whatever variable you want, but I'm going to use x. And then you have to decide what your boundary number is. So it looks like here, x, the dot right here is at -1. Okay, now open circle or closed circle is what you want to look for. Because it's a closed circle, you're going to have that or equal to. And then think about, x represents the numbers that you shaded. Did you shade numbers that were greater than -1 or less than -1? Because 0, 1, 2, and 3, those are all greater than -1, your inequality is x is greater than or equal to -1. Okay, and for part B, we're going to have an x, and then we're going to have a 4, because 4 is where your circle is. Now this time, you're not going to have a line under it, because it's just going to be less than or greater than, because it's an open circle. And what you shaded here, these are all numbers that are less than 4. So your inequality is going to be x is less than 4. And then the last part here, problem 5, real world inequality. So it says, what inequality describes a situation? Be sure to define a variable. Again, you can pick whatever variable you want, but you just have to say what it represents. So you have this picture here. It has horses and it has trail rides, and it says their starting price is $19.99. And you see that all the time. That means they're starting at $19.99. You're not going to get a cheaper trail ride. The prices might get higher depending on if you go for 5 hours or 10 hours or whatever, but the starting price is $19.99. So this is just what the book suggestion was. They said, let C equal the cost of a trail ride in dollars. Okay, so we have C. Now, if they're starting at $19.99, that's the lowest you're going to get. So all your trail rides are going to be greater than or equal to, because it's starting at $19.99, so you might have a ride that costs you $19.99, greater than or equal to $19.99. Okay, and then part B, this is a speed limit sign. So they said let S equal the legal speed in miles per hour. Okay, now, I don't know where they got this sign from. I've never seen 8 miles per hour, but if this is the legal speed, when you have speed limit signs, you can go up to 8 miles an hour, but you shouldn't go over. So think about your appropriate speeds. Would you be allowed to go 7 or would you be allowed to go 8? The speeds that you would be allowed to go would be less than 8 miles an hour. So the speeds you can go would be less than or equal to, because you could go 8 miles per hour. So your speeds are less than or equal to 8, and that would represent 8 miles per hour. Last part, this is just my suggestion. On page 167, I think they have a really good key concept box. If you already wrote down that one from a couple slides ago, it just does the same thing. It has the inequality written out in words, it has the symbol, and then it has what the graph looks like. So if you feel like you want everything from this lesson kind of all, shrunk down into one nice little box, I would copy down that key concept box, but you don't have to. Alright, that's it. Good job.